Hello viewers, in today's class we are going to discuss one important problem from continuity of a function, right? So here we have to deal with this problem, that is find the value of k if f of x is continuous at x is equal to 0, right? And here the function f of x is defined as tan of greatest integer of e square x square minus tan of greatest integer of minus e square x square divided by sine square x whenever x is not equal to 0, and f of x is equal to k square minus 1 when x is 0, right, where k is some real number, right? So here we have to find the value of k when we are given that this function f of x is continuous at x is equal to 0, right? And moreover here we see that we have the greatest integer function involved in this problem, right? So we have to take care of this greatest integer function, right? So let us start. So now let us first quickly take the definition of the continuous function, right? Now from differential calculus we know that a function f of x is said to be continuous at some point x is equal to a if the limit x tends to a of f of x is equal to the value of the function at that particular point, right? So here this is the definition of the continuous function. A function is said to be continuous at x is equal to a if limit x tends to a f of x is equal to the value of the function at that particular point, right? And here we should remember one thing, that whenever we talk of this limit, that is limit x tends to a, it implies that here both the right hand limit and the left hand limit are included, right? It means the right hand limit and the left hand limit both exist and finite and they are equal, right? So then we define limit x tends to a f of x, right? So now here we'll straight away find out this limit, that is limit x tends to 0, and we have f of x, and we have limit x tends to 0 and tan of greatest integer of e square x square minus tan of greatest integer of minus e square x square divided by sine square x, right? Now here we have the exponential number e, and we know that the value of the exponential number e is approximately, it is 2.71, right? So here we see that we have greatest integer of e square and here greatest integer of minus e square. So the approximate value of e square is given by 7.344, right? So e is approximately 2.71 and e square is approximately 7.344, and minus e square is approximately minus 7.344, right? So now let us use the definition of greatest integer function, right? So we see that e square is greater than 7, right? Because e square is approximately 7.344, so e square is greater than 7 but less than 8, right? So now from the definition of greatest integer function, the value of greatest integer of e square is equal to 7, right? Because the greatest integer of x is the greatest integer less than or equal to x, right? So the value of greatest integer of e square is 7, right? And similarly we have minus e square is minus 7.344, so minus e square is greater than minus 8 but it is less than minus 7, right? So again, by the definition of greatest integer function, we have the value of greatest integer of minus e square is equal to minus 8, right? So now we can substitute this value and this value over here. So we have limit x tends to 0, we have tan of greatest integer of e square is 7, so we have here 7x square, and here we have tan of minus 8x square divided by sine square x, right? So this can be simplified as limit x tends to 0, this is tan 7x square, and here we can take this negative sign outside because we know that tan of minus theta is equal to minus of tan theta, right? So now we have here plus tan 8x square, and we have sine square x, right? So now we have this limit to evaluate, and in order to evaluate this limit, we'll make use of two important results from limits. The first one is limit say theta tends to 0 and tan theta over theta is equal to 1, and the second one is limit theta tends to 0 sine theta over theta is equal to 1, right? So in the subsequent steps we are going to use these two results, right? So let us first transform these terms to this form, that is tan theta over theta and sine theta over theta, right? So what we will do, we'll write limit x tends to 0. See here, tan 7x square can be written as tan 7x square, and we can write here 7x square, and then we can multiply it by 7x square, right? So that we get this term, that is tan theta over theta. And similarly we'll do the same thing with this term, that is tan 8x square over 8x square, and here we can multiply by 8x square, right? So here again we'll get the same form, and in the denominator we can write sine square x over x square, and here also we can write x square, so that we get the form sine theta over theta, right? So now we can see here, we can take this x square and this x square common, and this x square will get cancelled with this x square, right? So now we are left with the limit x tends to 0, and we have tan of 7x square over 7x square times 7 plus tan 8x square over 8x square, and here we have 8, and in the denominator we have sine square x over x square, right? So now if we look at this step, we see that now we can directly apply this result to this expression, and similarly this result to this one, right? So here we have limit x tends to 0, and here we have we can take 7 outside, so we have limit x tends to 0 tan 7x square over 7x square, and then we have 8 times limit x tends to 0, and we have tan of 8x square over 8x square, and divided by limit x tends to 0, and we can write it as sine x over x, because this is square and this is square, so we can write here whole square, right? So the limit x tends to 0 of f of x is given by this expression. So here we have 7, this 7, and here we have 1 because this is limit theta tends to 0, tan theta over theta. And here we have 8 times again 1 because this is of this form. And here we have 1 square, right? Because limit x tends to 0, sin x over x is 1. So this is 1 square, and this is 7 plus 8 over 1, that is 15, right? So the limit is equal to 15, right? And we know that a function is said to be continuous at x is equal to 0 when this limit, that is the limit x tends to 0, f of x should be equal to f of 0, right? And this limit is equal to 15, and here f of 0 is given by c. Here we have x is 0 when f of x is k square minus 1. So f of 0 is equal to k square minus 1. So here we have k square minus 1. So this is k square equal to 15 plus 1, 16. And k is the square root of 16, that is plus minus 4, right? So the value of k for which this function is continuous at x is equal to 0 is given by k is equal to plus minus 4, right? So viewers, this is how we solve this important problem.